Everybody, why don't we get started? It's great to see you. I'm Ben Holton. I'm professor of global development and ecology and evolution. And I'm also the Dean of Cal, turns out. So I'm delighted to have the opportunity to introduce Ramanathan today, who is going to provide this lecture. And he's also providing another keynote on Thursday for the 2030 project. So if you don't get enough of Ram, there'll be another opportunity on Thursday. So, brief introduction. Ram is the Edward A. Freeman Endowed Presidential Chair in Climate Sustainability at the Scripps Institution of Oceanography, University of California, San Diego. And he's also an adjunct professor of climate change solutions right here in the Department of Global Development. This is his first trip out to Cornell since joining the faculty as an adjunct professor. Ram has contributed to many areas of the atmospheric and climate sciences, including developments to general circulation models, atmospheric chemistry, radiative forcing, and he's also been a part of some major league projects such as the Indian Ocean Experiment and the Earth Radiation Budget Experiment. He is known for his foundational contributions in climate physics, climate change, and atmospheric aerosols. He's also the chair of the Bending the Curve Climate Change Solutions Education Project at the University of California, which has now, I don't know how many institutions are involved in this. 14 institutions. So a great way to start bringing climate education into the classroom. And due to his close affiliation with Pope Francis, Ram is described as the Pope's climate scientist, which means he gets into heaven twice. And he's also been a close advisor to Governor Jerry Brown and helped advance California's science-based solutions to climate. Ram's honors also include the UN Climate Champion in 2013, election to the US National Academy of Sciences and the Royal Swedish Academy of Sciences, Foreign Policy 2014 Thought Leader. In 2018, he was named the Tang Laureate for Sustainability Science, and in 2021, the Blue Planet Prize, which I believe he will be receiving next week in Japan. So on top of all this, personally, he has been one of my most trusted colleagues, valued mentors, and friends since about 2015. And through a set of chance encounters at the University of California, Ram and I embarked on journeys to try to build collaborations in climate science and solutions. And he has really helped guide my academic journey and awakened me to a focus on building bridges and leading through collaboration. And he's a great example of translating science for the public good. So in his talk today, he will be focusing on building resilience against climate stress and shocks, the role of academic institutions. And please join me in welcoming Ramanathan.
Thank you, Ben. Can you all hear me on the back? Great. A very generous introduction. In 2015, two amazing things happened to me. One was having the audience with Pope Francis. The second was audience with Ben Holton. That's when our interaction started, if you remember. And so let me quickly explain what the title means, resilience. I know it happens to me all the time. You'll forget everything about what I said in probably less than a week. But if you could just remember what I'm going to say the first 2 minutes. So, I've been mainly focused on the science of climate change, and particularly my work is quite esoteric. How the gases trap the infrared heat. It's a combination of quantum mechanics and differential integral equations, etc. And I never thought about doing anything about climate change. I just thought about doing the science. And somehow in the last 10, 15 years. And the interaction with the Vatican played a big role, that I started seeing it as my responsibility. And I hope none of you make that mistake. That takes you on a different journey. On climate change, particularly, it's a pretty painful journey. You just see society, scientists are given warning after warning after warning. So until about like 10 years ago, we had the luxury of thinking about this as a mitigation problem. All we have to do is bend the warming curve. How do we bend the warming curve? Bend the emissions curve, right? We can't do that anymore because the climate extremes is already upon us, right? And it's just going to get worse before we figure out how to bend that curve. And billions are affected already. In the last 25 years, 4 billion were displaced cumulatively. Okay, this is all UN statistics. So we need to bring in adaptation. So that's where the concept of resilience comes in. Let's not think about it as climate mitigation. Let's think about building resilience. And mitigation still plays an important role, and then adaptation. But the third is, we all know already, I think all of us have figured out, this is just not a technology problem. If it was just a technology problem, we would have solved it. It is a technology problem, but also societal transformation problem. We just need to change our way of how we see and treat each other and how we see and treat nature, right? So those are the three. We need 3 pillars. We need for resilience. So now we can go to sleep for the rest of the talk. I'll tell you what I'm going to say. This cartoon, I gave a talk at the Cambridge University. They have a Center for Existential Threats. So they invited about 4 of us to talk there. And they employed a professional cartoonist to summarize each talk in one cartoon. And this cartoonist did an amazing job. He's not a science, he's an artist. And I use this. Stephen, is this the one which gives the pointer light? I don't want to hit the wrong thing and change something.
There it is, the top one. The top one.
Oh, yeah, right. So, what does it say? As scientists, we hold all the right cards. We know what to do. Just talked about Hearth. It's bend the emission curve of methane. And that will quickly bring the warming down. Quickly meaning 10, 20 years time scale. Okay? So we know what to do. And we also know when we should do it. We have at the maximum 10 years. What we scientists have not thought about how much is how to do it. How do you implement it? But I must say, I'm not trying to, overly praise Cornell. Of course, they paid my travel, so I had to praise them. But this is already stitched into your DNA, taking basic science and translating into solutions. If you doubt what I said, I'm sure many of you have not seen it. When you walk upstairs to Ben's office, look at on each stairs, they've written a statement. It's just all about taking your knowledge, working for the common good, okay? So many of you here, I'm just preaching to the choir, but please bear with me. So the issue, what we don't have the support, public support. When I say this, the people who do statistics, oh no, 70% of Americans trust climate change or believe in climate change. No, if you do a survey, ask Americans, list the top 3 problems we need to solve, we don't make it there. That's the issue. And as we all know, I'm not a political scientist, we are divided into 2 countries, no matter what the issue is. And climate change got put into that basket of issues which divide us. Okay, so we need public support. We need money, lots of money. The estimate varies anywhere from about $2 to $10 trillion per year for the next 20 years. Okay, so that's how a huge problem. The key where we can help out is come with scalable solutions. So that's what I'm going to emphasize today. So where did my journey begin? I'm going to walk you for the first 5-10 minutes. How did I get into this mess of talking about resilience? So my journey began, this is a South Indian village, and the next door is my grandfather's house. And his house got washed away about 20 years ago. And this is the veranda I used to sit, topless, with other topless kids in the village. Why? It's just too hot to wear anything on you. And why are we sitting on the veranda? Inside the home is too hot. Typically, by the time you leave the winter, spring, it's between 80 to 90 degrees. And the humidity is the most oppressive thing, 70 to 80%. And we can't step on the street. None of us had sandals. The biggest adaptation for these kids is to get them sandals. So that's at that level it starts. So how did such a topless kid thrive in this country and talk to some of the most brilliant minds? I had lots of help from India and from America. One thing I'll say to my credit is I always had a plan B for everything I do. Today's talk, I had 2 plans. In case my flash drive I lose things. So I sent Dropbox link. It so happened that Dropbox link reached Marianne 5 minutes before she came here. So I was here, my plan B worked. There was only one thing in my life I didn't have a plan B. Was when I asked my wife, who was there, to marry me. I had only one plan. For me, by sheer dumb luck, it worked. So the next thing, where did my resilience journey begin? See, I visited that village on my 60th birthday. And I was doing an experiment at the Maldives with unmanned aircraft. So I returned to Maldives. This was 2004, waiting on my email. It's the first letter started, this is Holy Father, St. Paul on the 2nd. What would you do? You would think it's a spam folder, right? I deleted it. Next morning, my good friend Paul Crutzen, who got the Nobel Prize for his work on ozone, wrote to me, Ram, did you get an email from the Vatican? I quickly went to my spam folder. Fortunately, I had not emptied it. It was an invitation from the Pope to join the Vatican. It's called Pontifical Academy of Sciences. And for the first year I went there, always I'll be afraid. I'm thinking, my God, they're going to find out I'm not a Catholic. They're going to find out I'm not even a Christian and fire me. Years later, I learned religious affiliation has nothing to do. Imagine, I know there's so many people criticize Catholic religion, but it's an amazing thing. They have this academy. There are only 80 members, 30 are Nobel laureates, mainly biology, medicine, and physics. anyone, and this is the oldest science academy. It started 500 years ago as Academy Lindsay. And then for a certain period when all the Catholic Protestant fight started, the academy was discontinued. They resurrected it 1940s. Anyhow, I started organizing series of meetings at the Vatican on climate change. That's when every time I give a title for a meeting, for example, the 2014 meeting, which then fed into the Laudato Si, that is Pope's encyclical for climate change, we said sustainable nature, sustainable humanity. The church will add the phrase, our responsibility. So that's worked in me for 10 years. This one, after the, we wrote a report, that was what Ben was, that's where I met Ben Holton from the University of California system. And this, the Pope, they asked me to help with the organizing of the Declaration of the Mayors. And they said, I can invite 3. The 2 are invited from the East Coast. I went to the Catholic Church of North America. So I wanted to invite from California just to get some brownie points from locally. I called the mayor's office. They didn't take me seriously. I don't blame them because Ramanathan, as he got to the Vatican, they thought it was a joke. So fortunately, I had contact with Jerry Brown's office. He immediately said yes. So you can see his signature there. Another thing, how much the church values science, the Pope had only 4 in the podium. The rest of them all mayors, all over Europe, China, India, everywhere. They seated me in the podium because they wanted to give importance to science. So enough advertisement about my good friend Francis, but I'm joking. I always address him as Holy Father. Oh. Oh. Yeah. So my climate journey began in India. I was an engineer, and I came to this country. My only hope was to quickly get a master's degree and join General Motors. That was my ambition. But didn't happen. My advisor switched his area to studying Mars and Venus. After that, I joined as a postdoc at NASA. Remember, that's when NASA was done with moon landing. So there were a lot of engineers sitting there, and they invented this term, mission to planet Earth. And 2 engineers there designed this Earth radiation budget instrument. And I was the only climate scientist they could find in that entire NASA Virginia. So they asked me to join. We got 250 million. Are there any postdocs here? How would you react if you won a $250 million project? Money was plenty those days. So what we did was designed an experiment to measure the greenhouse effect on the planet directly, how much heat is trapped, and how clouds were regulating. So I convinced them calibration is key. Till then, all the Earth observing instruments, they were not calibrated. So we put in the thing, a calibrating radiometer. So we would take all these instruments, look inwards. Then we thought that radiometer would degrade with time. We wanted this to play for 10 years. And so the engineers came with the idea they would, every 2 weeks, they would turn the satellite belly up and look at the moon. So we hypothesized moon is not changing, so we look at the moon. So we had the most precise data and how much heat was being trapped by these gases in the air. And then I joined Scripps, which is all about experimental observations. So I designed UAVs, miniaturized over 10, 12 instruments in each. The wingtip to wingtip is about 1 meter. And we were able to fly 3 aircraft 2 miles apart, but flying exactly same. That's the only way we can measure how much heat is trapped in the planet. So that's where I started on the science. So now I'm going to tell you how I went all over the place after that. So in 75, my entry into climate change came from this discovery that chlorofluorocarbons, which are used as refrigerants and propellants, per ton, they were 10,000 times more potent than CO2. Okay, so that launched a whole new area. Many went hunting for other gases. Methane came after that, and then nitrous oxide, et cetera, et cetera. That made it to the front page of New York Times. And Walter Cronkite, if you know Walter Cronkite, then I know your age. You must be at least 65 or older. He was the most popular CBS newscaster. So he interviewed me, but it didn't make it to the evening news. I remember with my wife, Kitty, was tuned on to the CBS, and there were only two reasons they didn't air it. One is he couldn't pronounce my first name on camera. Second is he called two faculty, one at Princeton, Jerry Malman, he was the director of Princeton GFD. I know him well. He said this is dangerous theory. I would think it was disrespectful. It turned out it was a lot more respectful than what a Harvard professor said. He said it's BS. So they didn't air it. It took the community about 3 to 4 years. I don't blame any one of them. Just to say one molecule is 10,000 times more potent than CO2, I had to redo my calculations at least 20 different times to convince myself. In any case, all of this at that time made it clear to me the whole climate change problem is a lot more severe than what we thought just with CO2. When you added all these other gases, they almost doubled the effect of CO2. So I got curious. We have to be able to see this effect if it's so large. So I teamed up with the famous meteorologist Madden, and we did what's called a statistical dynamical study. When can we see the climate signal from the noise? You know that year to year, so much noises. So we predicted that if this theory is right, the warming should be detectable by 2000. If it's not, then we know the theory has to be questioned. And it turned out it was in 2001. IPCC, the UN Committee of 700 scientists, said there is a discernible warming. Just got out of the signal. So, I mean, it just can't believe our science was able to predict it. Remember, that's how you judge scientific theories. Make a prediction with it, right? So this is my 30-second summary I give in my lecture about the science. So what's going on with CO2? Since Mr. James Watt invented his steam engine, we have emitted 2.4 trillion tons. Can you imagine that? Do you know how much is the solid junk we throw every year? Our trucks, our cars, every garbage we put outside. Entire world is 2 billion tons. So there is 1,000 years of solid waste we have put in the air. The sad thing is our eye can see solid, our eye can see liquid, our eye cannot see gases. They just don't scatter light enough. That's why you don't see them. About 1 trillion ton, 45% is still there. How do we know this? It's Dave Keeling, the legendary guy, it's called Keeling curve, and others measure CO2. And you see every year how much it's increasing and convert that into tons. Okay? So this 1 trillion tons of carbon dioxide is surrounding the planet like a blanket. See, everyone used to call it a greenhouse effect. Somebody trained in radiation physics, no, that's not a right word. So I've been trying to change the word from greenhouse to blanket since 1980s. Now you will see even New York Times would say blanket of gases. So that's a better metaphor. How does a blanket keep you warm? It doesn't give you any heat. It just traps your body heat, puts it back at you, right? That's exactly what it does. The Earth gives out infrared radiation. The atmosphere gives infrared radiation. They all escape to space, except for this blanket. Okay? So CO2, remember, we are just adding to it. There was already CO2 in the air. Without that, the planet would be frozen. So it's a classical issue of consumption. We need CO2, just like butter and sugar. It's amazing, but just too much of it is going to clog up your arteries, right? So that's exactly what's happening. CO2 by itself is not a villain. Too much of it is. And about 44% of the heat we track down is due to non-CO2 gases. So now we get in the warming. Most of us are now convinced ourselves with compelling evidence the warming we are experiencing is unprecedented. There's no way you can say it's natural variability in this, that, and the other. Okay. So these are some of the evidence for calling it. This from the IPCC. The CO2 concentration is the highest we have at 410 ppm in the last 2 million years. Sea level rise, fastest we have seen. Arctic sea ice, glacier retreat, everything is unprecedented compared to the last 2,000-3,000 years. What has changed? Remember I told you the signal came out of the noise in the year 2000. There is another signal came out of the noise by 2010, weather extremes, right? You can't take, it's very difficult to take in weather extreme. Like if you have a heat wave, oh, that's due to climate, you can't. What you can make that is a statistical statement. The probability of the extreme has increased. So in the last 40 years, hot temperature extreme increased 180%. No wonder we see every day about heat waves. Heavy precipitation increased 30%, particularly you see it in the East Coast, Midwest. When it rains, I don't think you're getting more rain, but when it rains, it pours. More of the water you get comes in fewer events. So the intense, that's why the flooding, Kentucky flooding. If that rain was spread over 2 weeks, there wouldn't be a problem. Remember Pakistan, third of Pakistan was buried in floods, water, okay? Agriculture and ecological droughts, I'll touch on it a little bit more, has increased 70%, disaster numbers increased 400%, et cetera, et cetera. But if you talk about this, there's already cost 2 million deaths. Just increased climate extremes and cost about $3.6 trillion. This is all the UN disaster agency estimates. So the question we have is, what is the connection between warming and weather extremes? How is it doing that? Why is the gradual warming creating the heat waves, hurricanes? It turns out when you warm the ocean, it evaporates more moisture. Just like you put a pan of water on your cooking range, it disappears. Why? Because you're trying to increase the temperature of the water, it evaporates. So what happens then? The air is holding more vapor. So if you ask, just in the last 2 years, I heard this. I was shown this slide. They say, oh, the humidity has increased by 6 to 7% per each degree warming. So what's the problem with that? Simply, the water has latent energy. When it goes into clouds and falls as rain, it releases that heat. That's why you get the rain. So what drives the meteorology, at least of the tropics, is the latent heat released by water. Okay? I think that's not what was in our mind. We were, I think, one of the first to show with real data. This is the microwave satellite data on water temperature, observed sea surface. We've done it over 1 year, 5 years, 10 years. This curve is always there. All it tells you, water vapor increases in the air by 5.5% per Celsius. If you did this measurement in your kitchen, there's an equation which predicts it that will give about 6.2%. So nature, there's some dilution. But it comes back as heat, energy. So there is a quantity which adds temperature and the latent heat. Convert that into an equivalent temperature, and that's called equivalent potential temperature. You don't have to get into the details of that. It's not something we invented. Meteorologists look at the nature like this. So when we plotted how that equivalent potential temperatures increase, this is the actual temperature, okay? The planet has warmed by about 0.7 degrees in that period, but the equivalent temperature doubled. That is the additional latent energy. Somehow, the climate community never thought of looking at this. One or two papers have looked at regions. So the thing which it changes, which is relevant to you New Yorkers, I mentioned the way I'm showing this. If you look at this and you read IPCC report, they say, oh, most of the warming is in the land. The ocean is delaying the signal. There's nothing wrong with that. But if you look at the equivalent potential temperature, the air over the ocean is heating up crazy. And it has to release that heat. That is what contributing intense storms. Okay? But at the same time, the air which goes up has to come down. So I'll tell you, we in California, when we look at storms hitting New York, we're just saying, oh, thank God we are in California, right? We're not saying that anymore. I'll tell you why. We are drying. We looked at the new, we looked at it, meteorologists look at the, how much the vapor is increasing in the air. And we looked at this quantity, which is change in the precipitation and change in the vapor drying. And I show this map to tell my Californians we are not alone. It's happening, entire Mediterranean is drying. So that's a 40-year record. Look at China, Australia, Africa, Amazon. I just remember this plot. I'm going to show you what's going to happen in the future. A model has predicted this. This was the fires off of Oregon last week, and this is off of Amazon. Okay. The one region I'm most worried about is this Amazon. Okay. And I'm going to lay out my plan B for the planet, just like I had a plan B for the slides. But remember this. So you can ask the question, You can ask, can it get any worse? That sad answer is yes, it can, due to what's called fat tails. For those of you who are not trained in the climate science, when we say the planet is going to warm by 2 degrees, there is no way we can have one number. It's just a 50% probability. What we don't tell you is a distribution of probable events that can happen. Okay? This should normally die down, but because of huge uncertainties in the system, it's called a fat tail. So there is a 5% probability the warming could be as high as 4 degrees when we say 2. Okay? So let me show you the 5% probability. This was a Princeton University study. If we don't cut the emissions in time, we are looking at this. Okay? The entire southwest parts of here, the Mediterranean is gone, Amazon. Somehow IPCC, what it does, it takes, there are 40 different models in the planet, thousands, they average everything. Okay? So many say, when I say 5%, 5%, I'm not going to worry about it, okay? But this is where the plan B, The plan A for the planet is already laid out by Ben, and I met Johannes, nature-based solutions. Treat the land gently, coax the soil to suck up that at least 500 billion of that 1 trillion. It's all possible. But we need to think about this too. If we don't do anything about it, if we get this situation, we have to think about the ocean. Okay? Right now, 98% of the food is grown on land. I thought it should be a lot more than that with the fish, right? We're causing disappearance of fish, but still 98% comes from land. I personally don't think that's going to sustain the 10.5 billion population. Ocean has to play a major role. It's up to us, academic institutions, to start thinking about how to sustainably and properly tap into the ocean resources. And the nature-based carbon extraction has to include the oceans. Okay, there are people at Scripps thinking about seaweeds and et cetera, okay? So those of you who tell me, 5%, I'm not worried about it. If I tell you there's a 5% chance that aircraft is coming down, none of you will get on it. If I tell you there's a 1% chance, none of you will get on it. If I tell you there's a 1 in 1,000, it's 0.01%, you still won't get on it. Why? The probability of air crashing is 1 in 5 to 10 million. That's right. So when it comes to our personal safety, we are scared about 5%, but we are sending our children and grandchildren, they have to get on that plane. Okay? So now briefly about the future. It is this paper which convinced me to work on resilience. IPC, this is a paper we published in Nature. This was my former student, he's at Texas A&M. David Victor is a political scientist at UCSD. So Weeks said, you're going to cross the 1.5 degree warming in 2030. IPCC was claiming it's not going to happen until 2045. Fortunately, something you have to know, when I published a study which is counter, I harass them. I keep sending the papers. Tell me how you got 2045. Finally, IPCC listened. In this report, which came out last year, they say early 2030. So we're all agreed on. So I don't know how the policymakers, a lot of leaders, they're going to keep the warming below 1.5. 1.5 is a done deal. In 8 years, there's nothing they can be able to do to bend that curve. So I call that's when you get the Montreal moment by 2030. So what do I mean by that? 1974 was the CFC ozone paper, which was published by Molina and Rowland. Mine came out a year later on the climate effects. 5 years later than that, British, I think they're meteorologists, discovered the ozone hole in the Antarctica. They had their station there, right? People listened. It has never, ever happened. In 5 years, Montreal Protocol came. 74 was the first 11 years we had a policy. Okay, climate, I'd show you. We have waited 80 years than some of the first papers, okay? But the Montreal Protocol, unfortunately, didn't pay attention to my work on the climate effect of CFCs. So they replaced CFCs with HFCs, which is about 2,000 times more potent than CO2. So my harassment of the policymaker started. I teamed up with Zalke. He's one of the best legal minds in environmental law. He's a lawyer. So we wrote this paper that mitigating HFCs alone would cut down the warming by about 0.5 degree. Okay. John Kerry was the Secretary of State, took it to the thing, and one of the instrumental persons to have the Kigali Amendment. So the Montreal Protocol has been amended to phase out HFCs. Okay. 136 countries ratified it. Unfortunately, this thing, late 2016, we changed hands. So the next government, US, didn't ratify it. So we're the only country who has not ratified it. And then Zalki worked with the Biden administration. It is being decided this week at the Senate. We have many Republicans supporting it. I was hoping I'll be able to announce it today, but I haven't heard anything. But it's going to happen this week. I'm hoping it'll be. So I waited 41 years from 1985 to this happen. So this is what I'm thinking. It's got a bad news, good news. I think when you press 1.5, if I just extrapolate what we have seen with 1 degree warming, I think of that somewhere around 2030, plus or minus 2 years, would be the COVID moment. Everyone would feel climate change. It'll be in our living room. So what do I mean by that? Either you would directly be impacted, or your relatives, your children, your grandchildren, or your friends, colleagues, you would know someone who was personally impacted severely. And I think that's when we'll wake up. Take the sort of drastic actions we need. What the Biden administration did is amazing, but it's nowhere close to what we need to do. Okay? So reason I'm going on this lecture tour, I'm now approaching various universities in mainly conservative states, Nebraska, in Pennsylvania, Texas, that we academic institutions can prepare for that moment, test our solutions, find out what are scalable, how do we transform society. That kind of a massive effort. On the plus side, whichever institution has the answers, they will take charge in saving the planet. That will be your reward. We did something which protected the planet. So let me just go to climate resilience. So what do we mean by it? We all instinctively know what resilience is. Then I found out there are 50 different definitions. So it depends on the context, depends on the problem, okay? So this is the one I think IPCC has also agreed with: capacity to prepare and plan for, absorb, recover from, and adapt to climate risks, right? So like I said, it took me 4 years to persuade the Vatican to have this major meeting. They brought in, of course, from all over the world, just 1 or 2 climate scientists. The rest of all were involved in solutions, societal transformation, et cetera, et cetera. So we just released a 5-page document. Joachim von Braun is a food scientist. He is the president of the Academy. Cardinal Turkson is from Ghana. So he's the chancellor of the Academy. That's the Vatican authority. And we are now very hopeful, he's the closest to Pope Francis amongst all the cardinals. So we have now direct access to Pope, but we are pushing for in this Egypt COP meeting to bring this, to make sure that adaptation has the same financial resources as mitigation, okay? And Pope Francis supported us, and he clearly says, I've spoken of an ecological conversion, demands a change of mentality. I am now more convinced after 50, and that is the key in our mindset. Somehow we have to worry if our emissions throws out women in Ghana and India out on the streets, okay? And the ecosystem. There's a major movement at Cambridge University from Partha Dasgupta. See, the problem, economists say, ecological economists, that we don't value nature. It's free, okay? So that's the issue. once you monetize nature, he has shown the world GDP is going down, not up. Okay, but we have to persuade macroeconomists about this, which is not an easy joke. In any case, so what we realize, this is another thing which is changing. We are not talking about climate change anymore. There are three trifecta of crises: climate change, biodiversity, inequality. All of them are interacting. For example, when you adapt, you can do what's called maladaptation and completely destroy what's little is left of the ecosystem. For example, I'm going to talk to you quickly about that. There are 3 billion who have not discovered fossil fuels. They can't afford it. They have access, but they can't afford it. So they have to resort to burning firewood and cow dung, right? So if you now throw another 10-degree warming extremes, how are they going to adapt? They're going to go to nature, okay? So we said resilience itself must stand on 3 pillars: mitigation, adaptation, and transformation. Mitigation to reduce the risks, adaptation to reduce the risk to manageable levels, then adapt to that, and then transform society. So what is risk? I'm taking this from this group of economists and social scientists. It's a product of vulnerability and threat. Threat, heat wave is a threat. Vulnerability, you are sensitive, right? I'm very sensitive to cold. I came from India. I'm in San Diego, where our temperature goes 72 degrees plus or minus 2 throughout the year, right? I become very sensitive to cold. So how do I reduce my exposure, right? And adaptive capacity. So the question is, how do you reduce the threat? Mitigate. So my point is, this is the big equation we are dealing with. We are just working on this to thinking that's going to take care of everything. It won't, because we delayed it. If you had done it early enough, of course that was enough. So this comes to the thing about what at UC we are doing. You know, we got all 10 campuses, 50 faculty, and wrote this report, 10 solutions to bend the curve. And so how do you mitigate? We said you have to pull on 3 levers. First is this non-CO2 pollutants. For many of them, you have the technologies, okay? And their lifetime is short. What does that mean? Methane. You cut the methane emissions. I think of cutting methane emissions, just maintaining your gas pipes, but Bob explained to me it's a lot more complicated than that. But still, you cut the methane emissions, just do with mental calculation, cut it by 80%. You can cut the warming by at least 0.3 of a degree in the next 20 years. Imagine that. You won't cross the 1.5. You would overshoot 1.5, come down, okay? This is, of course, the CO2 problem. I think I'm not going to talk about this. This is, I put the biggest thing also, which will have the biggest impact on the future of our children. We got to take that at least 500 billion tons of CO2. There's 1 trillion already. If you take next 30 years, we'd have put another 500 billion. Okay? We have to take it out. The key is, where are you going to put it? Okay? Think of the landfills. We don't know how to bury our solid waste. How are we going to bury the CO2? So in terms of adaptation, of course, reduce the sensitivity, reduce exposure. How do you reduce exposure? If you have a coastal property, move your house 10 kilometers inside, okay? I'm just making them all simple, just giving you some examples related. But the key is this, adaptive capacity. Just to tell you how Americans are adapting, 70% of recent home buyers are now considering fire risk before they'll buy. So if you're interested, go to realtor.com. They tell you each house. So it's already coming. Okay. And now I want to talk about the issue I'm most passionate about, and which I've been working at least the last 10 years. We took a sabbatical, and my wife and I started in a southern village where I grew up in, and we moved gradually north all the way up to Himalayas, staying 1 or 2 weeks. So this woman's house is where I stayed in the Himalayas. Okay, cold. That's all she has. Burning wood. Just imagine that's about 6,000 feet altitude. I want to ask who's responsible for this? For me? Or the wealthy in India? Okay. So 40% of the population earn less than $10 a day. Imagine that. Another 45, 10 to 30. So I have divided the world into 3 worlds. I see 3 worlds living parallel. I call them the bottom 3 billion, 40% of 8 million. This is the next on that. This 1 billion, I belong in that 1 billion. We own 75% of the wealth. So when it comes to who has to take charge, mitigating, adapting, the answer is obvious. Okay, they just don't have the money to do anything about it. This 40% of the population, their total greenhouse gas emission is 5%. Okay, so then about 40%, I don't know if these 40 or same population live with high climate vulnerability. I would put about 4 million Californians live in that. Okay. And my daughter-in-law, who's a neuroscientist, studied, she looks at mental health, and she found the Paradise Fire, which is the worst fire experience. Half the town developed PTSD and severe mental depression. Not only those exposed, but those who were exposed to the exposed. The children of them are relatives. Okay, so it's gone to serious proportions when you start thinking about this. So the question is, and also the high and upper middle income, half the population is responsible for most of the emission, 85%. The other half is just, on our leftovers. Then move on to the biodiversity. The loss of species. There's a huge group which has started now, just in the last 4 years. And you will start hearing, I bet, from now on, somebody says climate change, biodiversity would go in hand in hand. They become very well organized. And apparently 1 million species are about to be extinct now. They're on the path to extinction. In addition to this, and they all conclude climate change is supposed to be the biggest single threat. So that's how we are impacting. Okay, 75% of the land and Sikkim Ocean are impacted, and over 80% of the wetlands area lost. That's wetlands is what's going to protect us from sea level coming all over. So until 4 years ago, I had a severe intellectual battle at Vatican. Can't bring in the Cambridge economists are pushing for biodiversity. I kept them apart, but now I have succumbed. Yes, biodiversity has to be dealt with. So this comes on the transformation. I see that we are very close to the ending time. Shall I take 5 minutes to wrap it up? That'll be 4:30. Maybe it doesn't have time for questions, or okay. So I'm going to give you an example of this, and I have no hesitation saying, Ben, you don't have to pay my travel. Cornell excels in it. I met with Johannes, and then I met with Bob, and I met with several. I talked to Bruce about what he's teaching. And If I had known he existed 5 years ago, I would have him lead the bending the curve education. He's already doing everything. 50 of us needed to do it. Okay. So this is my stuff, but what is it we academics should do? Of course, we excel in curiosity-driven science. That cannot be compromised. That has to continue. That's what drives it. But we need to, this many universities are doing it. What stuff is, that is not enough. We just thought we do this, publish our reports, people will read and solve the problem. It's not happening. So what's being pushed for, this mainly the push is coming from places like Cambridge and Germany, the Potsdam Institute, that we need to integrate with transdisciplinary research. What does that mean? Bringing in the community. I certainly would include faith-based institutions, NGOs, private sectors, government decision makers. In here, we discuss with them what the solutions we have. And of course, half of them they find is too theoretical or non-practical. So it's together we figure out what is scalable. See, the key issue now is what is scalable. For example, we put a heat pump in my house. Just it cost $40,000. I didn't want fossil fuel coming into my house because I'm preaching everyone had to go fossil free. But then I decided if it's 40,000, that's not scalable. But 85% of the planet is earning less than $30 a day. It is scalable for us, for the top 1 billion. So I'm not putting it down, but we need to see if we leave the other 4 billion, I'll show you the catastrophe. So I'm just going to skip all this. There is a big push now to bring humans into the models. Our climate models are behaving as if we are already extinct. There are no human beings there. We just prescribe what to do. So now there is a big push to bring in human behavior, and that's what I worked on last 4 or 5 years. So that's our natural system model, right? We do everything there. But this is the human behavioral system which decides how much fossil fuel to use. And then when the warming increases, the society responds. But all of that takes time. From science to policy response, we found takes about 15, 20 years. From policy response to technology development, and then scaling up that technology, it's called diffusion. That takes 10, 15 years. The doubling time is about 6 years. You have 1% solar today, it'll take 36 years to go to 65%. That's 6 doublings. Okay? These are the things not in our model. So we published this. What we found from the time you decrease your emissions and the time warming curve bends, 50 years gap. It's not only the response time of nature, it's the response time of society. Technology diffusion, you have to persuade the Elon Musks of the world to cough up their billions, right? And persuade the government. I want to conclude with this. If we go on our current course, let me give you statistics when I say current course. When do you think was the highest fossil fuel emission? Last year. We are still on the up curve. Okay? So we are talking about 3.5 degree warming with a large spread. But if we don't provide for adaptation and you leave it to them to access whatever fuel they have, they're going to burn coal. Okay, that's the cheapest. We find that alone would add 1.5 degrees to the warming. No model that I know of has included that. I'm worried sick about that. Meaning, how come people have missed this? So no one is talking about the climate change effects of adaptation. If we don't share our technology and sort of give them to almost free, They will access the fossil fuel companies, right? They will offer the fossil fuel companies, once we mitigate the top 1 billion, will be looking for customers. The 3 billion will be their customers. But fortunately, there is still to push this whole thing here, where the warming peaks at 1.5. That's the hopeful sign. I am hopeful the Montreal moment will do. Otherwise, I retired from UCSD. I wouldn't have accepted the honor of Curtis. I would be relaxing with my grandkids. I think there is still a chance. Okay. So I'm just going to skip all the things UC did. We developed this bending the curve course. And then Ben and I started this California Collaborative for Climate Solutions. I had the 10 campuses lined up. Ben brought Caltech and Stanford. All of that, we developed a program of about 40 different solutions. It was amazing. So what I want to share with you, Ben, in the question session, you can offer. There's tremendous commitment on the faculty side to take it as our responsibility and we want to do. The institutions have to find a way to reward it. Okay. And so there is tremendous hope there. Okay. So what I'm thinking, academic institution, do we feed the translation of research into solutions, move solutions to demonstration pilot projects? The third bullet got below, that's basically scaling up, find scalable solutions. Who knows about this movie, Who is Minding the Store? Then I will age you. You must be at least 70 or older. It's a 1960s movie. This is the question I ask myself. Who is minding the store when I find none of our estimates have included the warming from adaptation? Who is looking at all these issues? Okay. And if there are some social scientists, I'm going to say it to provoke you to a response. I don't know why social scientists are not looking at this problem. How do we bring Americans together? Unpack climate change from all the things that separates us and tell them, no, climate change has nothing to do with all the other issues, gender, abortion, racial issues. It is a separate issue. All of us are going to go under, whether you're Republican or Democrat. I personally have found, I'm trying this, talking in churches, faith-based institutions, is the only politically neutral forum I can think of. I've talked to close to 5,000 so far, at least 3 or 4 evangelical churches, the rest are Catholic churches. And imagine with my name and my religious origin talking in churches, people accept. I'm talking about places like Nebraska and in conservative churches, in Minnesota and California. I don't know how many of you know in the Central Valley where the agriculture is done, you can't mention the word climate change. And so far, my experience with them is always they ask me, Professor Ram, we didn't know there was so much science behind this. We thought it is all an attack on religion. So there is things like that we can help. I'm going to end there. Thank you.